Hello grade 11s and welcome to the Junior Techie grade 11 Physical Science Summer School with me, Natasha Barton. In this series of videos, we're going to be taking a look at the different types of questions that you may find in a paper 2 grade 11 Physical Science exam. We are, however, going to skip the multiple choice questions, so you're not going to see any multiple choice questions in these videos. Grade 11s, this does not mean that multiple choice is not important. In fact, multiple choice is incredibly important, and often the difference between the marks that you want and maybe the marks that you're getting that you don't really like. So please do yourself a favor, go onto the internet, get a few past papers, and please be sure to try the multiple choice questions as well. But for now, we're going to be looking at a few longer questions. Starting off with question number 1, which deals with bonds and the different structures of molecules, so bonds and molecular structure. As always, I do recommend that you start off by pausing the video, trying the questions yourself, and when you've completed the questions, go and watch the video or continue to watch the video while marking or working through the problems with me. In this way, you'll be able to identify what concepts you don't really understand, and you'll be able to correct your mistakes so that you make those mistakes now and not in your November exams. So please be sure to still watch the videos and correct your mistakes if there are any. If not, then you know that we're just reinforcing all of the correct ideas that you already have. So, in order to answer this question, it's important that you're familiar with your periodic table. This is a periodic table of the kind that you would be given in a November exam. We know that in this section, we often speak of valence electrons. Those are the electrons in the outermost energy level of the atoms, and they are responsible for bonds forming. So if we look at the group 1 elements, they contain, or their atoms contain 1 valence electrons. Group 2 contains 2 valence electrons. We look at the traditional group numbers 3, 4, 5, 6, 7 given by the Roman numerals, and we therefore know that group 13 has 3 valence electrons, group 14 has 4 valence electrons, and so on, so forth. Be sure to make use of your periodic table in order to determine the valence electrons in each atom. Electronegativity is also another very useful value that you're going to find on your periodic table. It's going to help you to determine what types of bonds are forming between atoms, whether they be polar covalent, non-polar covalent, or ionic bonds. They're also going to help you to determine if the entire molecule is either polar or non-polar. So, please note that you're going to find the electronegativities of the different atoms on the left-hand side of the atom symbol. Let's now answer the questions. Question number 1.1 says, consider the following molecules and answer the questions below. Draw the Lewis structure for BeCl2. Now, you may look at this molecule and say, but beryllium's a metal and chlorine's non-metal. Should we not have between them ionic bonds? Although your thoughts are more or less correct, beryllium is a special type of atom, and that is why in this case, beryllium chloride is a molecule. Remember that the term molecule is only used to refer to substances that contain covalent bonds. So this is a special type of molecule that contains a metal covalently bonded to a non-metal. In order to draw the Lewis diagram, we can make use of the lengthy procedure that ensures that we make use of or apply the octet rule. But the easier method is to start off by seeing if we can pair up unpaired electrons. So let's start off by drawing the Lewis diagrams for the 2 chlorine atoms. We're going to write down Cl and Cl, and the Lewis diagram for beryllium, which is Be. We go to the periodic table to determine the number of valence electrons in each of these atoms. Since beryllium is in group 2, it has 2 valence electrons, and since chlorine is in group 7 or 17, it has 7 valence electrons. We are going to represent the valence electrons using dots and crosses. Beryllium has 2 dots. Chlorine, or each chlorine atom, is going to be surrounded by 1, 2, 3, 4, 5, 6, 7 valence electrons. And we do the same on the right hand side, because this one will also have 7 valence electrons. Notice that this electron is unpaired and it can pair up with one of the unpaired electrons in beryllium. This one over here is also unpaired and it can pair up with this valence electron from beryllium. So pairing up the unpaired valence electrons, we find that the Lewis structure for beryllium chloride is given as displayed to your screen. For this entire structure being correct, you're going to get 2 marks. So in this case, it is 2 marks or nothing. Question B now requires us to draw the Lewis diagram for ammonia, that is NH3. Nitrogen is in group 5, so it contains 5 valence electrons. 5, or we can say group 15 using the modern number. Hydrogen is in group 1 and it has 1 valence electron. Fortunately, hydrogen is always a terminal atom, so we can go ahead and draw the nitrogen with its 1, 2, 3, 4, 5 electrons, and then we can go ahead and draw in the hydrogens immediately. So we're going to have 1 hydrogen here, 1 there, and 1 there. Each one comes with its own valence electron, 1 valence electron. And this here is the structure for ammonia that you're going to be given 2 marks for. Again, it is all or nothing. We now can go on to question 1.1.2, which is indicate whether the covalent bonds in the following molecules are polar or non-polar. They are asking us to state whether the bonds are polar or non-polar, not the entire molecules. In order to determine if the bonds are polar or non-polar, we check to see which atoms are bonded. In HCl, we have hydrogen bonded to chlorine. Taking a look at the periodic table, we see that hydrogen has an electronegativity of 2,1, while chlorine has an electronegativity of 3. So that is 2,1 and 3. Since chlorine has a higher electronegativity, we know that chlorine is going to be slightly negative, while the hydrogen atom in this bond is going to be slightly positive. This is therefore a polar bond, and to answer the question, we write down the word polar. For writing this down, we're going to be awarded 1 mark. N2 is the nitrogen molecule. It's made up of 2 nitrogen atoms that are bonded to each other, N bonded to N. So, in this molecule, we have 2 of exactly the same atom, each with an electronegativity of 3. We think about this as a tug of war. Since they both have equal strengths, they're going to share that pair of valence electrons, that bond pair of electrons equally, and therefore the bond in this nitrogen molecule is going to be non-polar. Neither nitrogen atom is going to be more positive or more negative than the other. The last substance is carbon dioxide. Now, if you've been studying very hard, you will remember that carbon dioxide is a linear molecule with a double bond between each oxygen and the carbon atom, which is the central atom. We are looking at the bonds in these molecules. So in other words, the bond between oxygen and carbon. We go to the periodic table where we find that carbon has an electronegativity of 2,5 and oxygen has an electronegativity of 3,5. That is 2,5 and 3,5. Clearly, we see that oxygen has a higher electronegativity, and in this bond, it will therefore be slightly negative, while carbon is slightly positive. That said, since there is a difference in electronegativities, we can say that the bonds in the carbon dioxide molecule is polar covalent bonds for 1 mark. Now we go on to question 1.1.3, which says define the term dative covalent bond. We say that a dative covalent bond for 2 marks is the type of covalent bond where both the shared pair of electrons, or both electrons in the shared pair, is given by one atom only. So we have two atoms that are going to bond together, but only one of those atoms is going to bring its electrons to form the bond. The other one will just have an empty orbital that will overlap with that pair of electrons, the lone pair of electrons. For writing this down, you're going to get 2 marks. On to question 1.1.4, which says, explain why the hydronium ion, that is H+, can form a dative covalent bond with NH3. Now, if you go and take a look at the videos that were created on the Junior Techie website for the chapter on atomic combinations and molecular structure, you're going to see that there's quite a lengthy or detailed explanation of what a dative covalent bond is. We say that in this molecule, the ammonia molecule is a central atom called nitrogen. And nitrogen has on it what we refer to as a lone pair of electrons. That is a pair of electrons that is not taking place or taking part in a bond. The nitrogen brought these electrons and it's not doing anything with them at this point. Now, if we take a look at the hydronium ion, the hydronium ion forms when a hydrogen atom, which originally has one electron, loses that one electron. So when it loses that one electron, it has one proton and an empty orbital. What is going to happen is that this empty orbital is going to overlap with this lone pair of electrons from the nitrogen molecule, or from the nitrogen in the ammonia molecule, So then we're going to have an H over here, and together this is no longer ammonia but ammonium, the ammonium ion, which has a charge of +1. So to answer question 1.1.4, we can say there is a lone pair of electrons on the central nitrogen atom in ammonia. That is going to get us 1 mark. And we can state that there's an empty orbital in the hydronium ion that can overlap with that lone pair to form the dative covalent bond. And that is going to get us the 2nd mark. So that is the answer to question 1.1.4, and this brings us to the end of this video. In the next video, we're going to continue with question number 1. And we're going to deal with problems that look at molecules as a whole and whether the entire molecule is either polar or non-polar. So please be sure to join me in that video.